Hello guys, this is Arash. In this tutorial I'm going to show you how to use my app so that you're not going to be confused when you want to use it. So you can choose between matrix solver and matrix inverse finder. When for example we choose matrix solver, um, you can choose between instant solver and the step-by-step solver. The difference is in instant solver it gives you the answer right away. It gives you the row echelon form first and the reduced row echelon form of the matrix, but it doesn't show you any algorithm that took place in order to reach that level. But in a step-by-step solver, it actually shows you each step in order to get to that, in order to solve a matrix. So let's first choose instant solver. You can choose between normal and augmented matrix. Uh, Actually, augmented matrix is for uh, solving a system of linear equations. So, for example, if you have, actually, let's try it. So this is row. When you tap, it increments. So 4 rows and 4 columns and 1 augmented column. So this actually means we have 4 equations and 4 unknowns, and this column is the answer to those equations. So for example, the first row means 2x plus 1y plus 1z plus 1w is 2. So it's useful for solving a system of linear equations, and you need to tap on each cell in order to increment it. If you it By default it increments by 1. If you want to change it, you can just click here, and if you, for example, want to increment by 8, you just make this 8 and it increments by 8. If you want to decrement, you make it negative, so -1, for example. So it decrements. You can also give it fractions like 4 over 3. Oops. 4 over 3, as you can see. So whenever you tap, it adds a 4 over 3 to that cell with each of your taps. So if you can make it that negative as well, you can give it 4.2 for example 4.2 as well. So let's now say go. Okay, so this is the rational form, as you can see, and this is a reduced rational form of that matrix. So let's now go to step by step one. Again, augmented, so 4 rows, 4 columns, and 1 augmented column. Let's give it some random inputs. So with each of my tabs, it increments by 1 right now. You should wait a little. So it's done. So you should press next to see each step. So this means dividing by the first non-zero entry, which is now 2. So dividing the row. This is a Gaussian algorithm. So first dividing each row by the first non-zero entry, which is 2 here. Dividing by 6. Dividing this row by 6. Dividing this row by 3. And the last one by 2. This means swapping, so swapping the second row and the third row. This is subtracting upper from the lower, so green one from the red one. Again, subtracting upper from the lower, dividing by first non-zero entry, subtracting upper from the lower, dividing, subtracting upper from the lower, dividing. So now we are in row echelon form, excuse me. Now we are going to reduce row echelon form. So in order to get there, now we have w is equal to minus 70 over 29, and in the upper row we have z plus 7 over 6w is minus 1 over 3. So we know what w is, so we need to figure out what 7 over 6w is. So we multiply this side by 7 over 6 and this side by 7 over 6. We negate it in order to when we want to, or so we make this 7 over 6, and we multiply this by 7 over 6, this one by 7 over 6 as well, and subtract it from the upper row to get rid of the w component. So now done. None of the rows except for the last one has the w component. Now we want to get rid of z component the same way. Now y component. Now we have x is equal to 27 over 29, y is equal to 21 over 29, z is equal to 72 over 29, and w is equal to minus 70 over 29. So this was for the matrix inverse finder. Matrix solver, sorry. Now in matrix inverse finder. Should when you tap on instant solver, this means so in order for a matrix to be invertible, it has to be a square matrix. So this means 1 by 1, this means 2 by 2. It increments when you tap. So this is 4 by 4. So let's give it some random input. So this is the inverse, and the inverse of the inverse, as you know, is the initial matrix. So yeah, so initial, inverse, initial. Now let's go to step by step. Here you see the algorithm that was used in order to get there. That is used actually. Let's wait a little. Okay, so determinant is 1 times 2 times 3, so those numbers come from each step, the operations in each step that we applied on the matrix in order to get to the inverse. So the determinant is 171. So in order to go to the inverse, we inject the matrix. So we make a new matrix in which it has an augmented part, and in that augmented part there's an identity matrix. So if our matrix is 4 by 4, the identity matrix on the augmented part must be 4 by 4. If our matrix is 3 by 3, it must be 3 by 3, so and so on. So now we just apply our operations in order to get to reduced rational form, and when we get there, if the matrix is invertible, the identity matrix on the augmented part right now becomes the inverse, and the initial matrix becomes the identity. So let's go actually. So this is dividing by the first non-zero entry, dividing by first non-zero entry, dividing by first non-zero entry, swapping two rows, swapping, subtracting upper from the lower, subtracting upper from the lower, dividing, subtracting, dividing, subtracting, dividing. This is, now we are at rational form, but we need to go to reduced one. Let's go fast. So now on the left part we see that we have an identity matrix, and on the right part what is left is the inverse on the green part, which is the augmented part. So this is the inverse. Thank you for watching. If you enjoyed my app, I really like I actually really like your comments. If you enjoyed it, please make sure you rate it on Google Play. Thank you very much. Have a good day.